Welcome to Module 2, Lesson 2, Linear Equations Word Problems. About 30% of the math questions on the SAT are set in a real-world context, right? They involve real-world problems, they involve word problems, and that's just really how we learn math these days anyway, right? It's not how your parents learned math. It's all about applying math to the real world. So 30% of the math questions are going to be word problems. We're going to take a look at a few of them and learn a strategy that can help you really break apart word problems if you're someone who typically struggles to figure out what these word problems are actually asking you to do. So we'll start with our level 1 beginner problems. We have this word problem here. Anton watched X movies in 2019. If Michael watched 1/4 as many movies as Anton did in 2019, which of the following best approximates the number of movies Michael watched in 2019? So the first thing you want to do here is look for the important information. So we know Anton watched X amount of movies. The number of movies that Anton watched is unknown, right? Michael watched 1/4 as many movies, right? So what does that mean? 1/4 as many movies as Anton did. That is the key information for this problem. So basically, we want to take 1/4 of the amount of movies that Anton watched. We know Anton watched X amount of movies. So that would be 1/4 of X, or 1/4 times X. Now, 1/4 of X, or X times 1/4, all we do is multiply X times 1, and we leave 4 in the denominator, right? Because this is basically multiplying fractions, and X is the same thing as X over 1. So you multiply the numerator by the numerator, X times 1, and you multiply the denominator by the denominator, so 1 times 4. We get X over 4, and that is choice A. So with word problems like these and word problems in general, most of the time you will either have to create your own expression or equation, or figure out which expression or equation suits the situation if it's a multiple choice question. So you do have to look for keywords in order to figure out which operation should be used in the mathematical statement that you're writing, right? So look for keywords that indicate addition, subtraction, multiplication, or division. Please pause this video and work on the Lesson 2 Level 1 problems in the workbook. Moving on to our intermediate level. Let's take a look at this word problem here. We are going to use a strategy called 3 reads to do this word problem, because now we're moving on to word problems that are a little more involved, and many of us struggle when we have a word problem to kind of figure out what the question's actually asking us. So using the 3 reads protocol is really going to help us break apart the problem and organize our work to set us up to solve the problem successfully. So in your workbook, you should notice that if you go to the course materials, I actually have a 3 reads template that I created that you could print out as many copies of, and you can use that template and fill it in as you're working on word problems. This will really help you organize your work. So let's start with the first read. We're going to read the problem 3 times. That's why it's called 3 reads. So first read. The width of a rectangular vegetable garden is W feet. The length of the garden is 8 feet longer than its width. Which of the following expresses the perimeter in feet of the vegetable garden in terms of W? So first read, what is the story about? All you have to do in this read is summarize the problem in just a sentence or two. I encourage you to not even think about math during the first read and just think about the story and the context. I wouldn't even include numbers in your summary. I would just write a short sentence or two about what the story is about. Moving on to the second read. The width of a rectangular vegetable garden is W feet. The length of the garden is 8 feet longer than its width. Which of the following expresses the perimeter in feet of the vegetable garden in terms of W? What are the quantities and what are the relationships? So while all three reads are important, the second read is the most important read. And that's because in this read, we're going to identify all the important information that you're going to use to solve the problem. So let's identify the quantities and relationships. The quantities are the important numbers and variables. The relationships are what the important numbers and variables represent. So I'm going to start by drawing a rectangle. Anytime you have a problem like this about a rectangle, a square, I highly encourage you to draw a diagram for yourself because it will make the problem solving visual for you. So we're working with a rectangular vegetable garden. So first, draw yourself a rectangle. So our quantities. We have W, and W represents the width of the rectangle. Now, we have 8, right? That is how much longer the length is than the width. But what about our length? What is our length then? So here's where you have to take W and 8 and write an expression to represent the length. So if the width is W and 8 represents that the length is 8 feet longer than the width, 8 feet longer means to add 8. So we're going to represent the length as W plus 8. And now the question is asking about the perimeter. So we're going to need to recall the perimeter formula, which is P equals 2L plus 2W. So if you notice here, if you fill in this quantities and relationships tables, now all we're going to do is take this information that we organized and we're going to use all of it to solve the problem. So before moving on to the third read, let's solve the problem. They want to know which of the following expresses the perimeter. So we're going to need to use our perimeter formula. So all we're going to do is substitute W plus 8, the expression we created for the length. We're going to substitute W plus 8 for L, and we're going to leave W as W, right? Because that's the width. We don't have a value for that. So we substitute into the formula and we get 2 times the sum of W and 8 plus 2W. Now we're going to simplify, we'll simplify our equation by using the distributive property. So we distribute 2 to W as well as to 8, and we get 2W plus 16 plus 2W. Now we'll combine like terms. 2W plus 2W is 4W, and we get 4W plus 16, right? And that is choice C. Now moving on to the third read. The width of a rectangular vegetable garden is W feet. The length of the garden is 8 feet longer than its width. Which of the following expresses the perimeter in feet of the vegetable garden in terms of W? What mathematical questions could you ask? Now, yes, we've already solved the problem, but extending your thinking by creating a mathematical problem, a mathematical question about this problem will just help you think deeper about the content, right? So something that you might ask is, what's the area of the rectangle, right? And that would encourage you to recall the area formula, which is length times width. So the third read is important as well. If you can create the question, then that shows a true conceptual understanding of the content. Let's take a look at another problem. A helicopter, initially hovering 35 feet above the ground, begins to ascend at a speed of 16 feet per second. Write an equation that can be used to find t, the number of seconds it takes for the helicopter to reach 179 feet above the ground. What is the story about? Please pause this video and fill out that section of the 3-read template. Moving on to the second read. A helicopter, initially hovering 35 feet above the ground, begins to ascend at a speed of 16 feet per second. Write an equation that can be used to find t, the number of seconds it takes for the helicopter to reach 179 feet above the ground. What are the quantities and what are the relationships? So let's take a look. We have 35. That represents the initial height of the helicopter. So now you have to recall that the initial height or initial value in general, right, is always going to be your y-intercept. This is going to be important when we get to writing our equation. Next, we have 16. That represents the speed of the helicopter per second. So that's your rate of change, which is going to represent our slope. Again, these two elements are going to be super important when writing our equation. Then we have t, our variable. That represents the time in seconds. We have 179, which is our total height. Then we have the equation of a line, our slope-intercept form, y equals mx plus b. And the reason why I'm putting this here is because we're going to use this form in order to write our equation. So now let's take all of the work that we organized in the second read and use it to answer this question. So we're going to use our slope-intercept form here, y equals mx plus b. Recall that y is the total amount, m is your slope, and b is your y-intercept, right? So if you look at your quantities and relationships table, 179 was the total height, right? So that's going to be our y value. M, our slope, was 16. So we have 16x. And then b, our y-intercept, was 35. So plus 35. Third read. A helicopter, initially hovering 35 feet above the ground, begins to ascend at a speed of 16 feet per second. Write an equation that can be used to find t, the number of seconds it takes for the helicopter to reach 179 feet above the ground. What mathematical questions could you ask? Well, now you could ask a question like, how high would the helicopter be after 10 seconds? And you would substitute 10 for your variable. You could ask questions like that. That is an extension of a word problem like this that you would probably see being asked on on either a multiple choice question or a constructed response question on the SAT. But those are just some questions that you can ask to extend your thinking about a problem like this. Please pause this video and work on the Lesson 2, Level 2 problems in the workbook. Level 3, our expert level. Let's take a look at this problem here. We are definitely going to use the 3 reads protocol for this question because you'll notice as we go through it, this question is very involved and there's a lot going on in this question. I highly suggest using the 3 reads protocol for a question like this. So let's take a look. Lawrence will mix X milliliters of a 10% by mass saline solution with Y milliliters of a 20% by mass saline solution in order to create a 12% by mass saline solution. Write an equation that represents this situation. If Lawrence uses 100 milliliters of the 20% by mass saline solution, how many milliliters of the 10% by mass saline solution must he use? What is the story about? Please pause this video and summarize the story in the first section of the 3 reads template. Second read. Lawrence will mix X milliliters of a 10% by mass saline solution with Y milliliters of a 20% by mass saline solution in order to create a 12% by mass saline solution. Write an equation that represents this situation. If Lawrence uses 100 milliliters of the 20% by mass saline solution, how many milliliters of the 10% by mass saline solution must he use? So again, we have lots of quantities and lots of relationships in this problem. So this second read is going to be essential in answering this question. So let's see what we have here. We have our variable X. This represents the number of milliliters of the 10% by mass saline solution. Then we have Y. This is the number of milliliters of the 20% by mass saline solution. Now we have 0.10, right? 0.10 is 10% converted to a decimal. We're going to have to write an equation here. And when we have problems that deal with percent, we have to convert the percentage to a decimal in order to work with those numbers. Then we have 0.20, which is 20% converted to a decimal. Again, when you're given percentages in word problems, you must convert them to decimals when writing your equations and working with them to solve. Then we have 12%, right, which will convert to 0.12. This is the by mass solution to be created, right? Notice how when I was reading it and I got to that point, I always emphasized the word create, right? Because that's going to be really important in understanding the problem and writing our equation. And then we have 100. This is the number of milliliters of the 20% by mass saline solution. So notice here there are 2 parts to this problem. The first part is to write the equation. And then in the second part, it asks if Lawrence uses 100 milliliters of the 20% by mass saline solution. So in the second part, we're going to have to substitute into the equation that we create. So let's first start by creating our equation. So we're going to start with 0.10x, right, which represents x milliliters of the 10% by mass saline solution, plus 0.20y, which is going to represent y milliliters of the 20% by mass saline solution. So now he's mixing these two by mass saline solutions in order to create, right? To create, which means if he's mixing them together, he's adding them together. When he adds them together, it will be equal to the 12% by mass saline solution that he's creating, right? So we're going to have 0.12 times the sum of x and y, right? And this is because it's 12% of what he mixed, right? That's what he's creating. So that is why we have the sum of x and y, right? X is the 10% by mass saline solution. Y is the 20% by mass saline solution. And he's creating a 12% by mass saline solution by mixing the two. So we have to add x and y on the right-hand side of the equal sign. So this is part one, right? That's our equation. Now they tell us that Lawrence is using 100 milliliters of the 20% by mass saline solution, right? So now we have the value of y. Y equals 100. So we're going to substitute 100 for y on both sides of the equal sign. They want to know how many milliliters of the 10% by mass saline solution must he use. So we're going to use this and now solve for x. So we'll simplify both sides. 0.10 plus 0.20 times 100 is 20 equals 0.12x plus 12. Now we have our variables on both sides of the equal sign, right? So we're going to collect them on both sides, and we get 8 equals 0.02x. We get rid of our coefficient by dividing both sides by 0.02, and we get 400 milliliters equals x. If you don't understand how I use inverse operations to solve for x, please go back to the lesson 1 video where we learned about how to solve equations by inverse operations. And the third read, Lawrence will mix x milliliters of a 10% by mass saline solution with y milliliters of a 20% by mass saline solution in order to create a 12% by mass saline solution. Write an equation that represents this situation. If Lawrence uses 100 milliliters of the 20% by mass saline solution, how many milliliters of the 10% by mass saline solution must he use? What mathematical questions could you ask? Please pause this video and fill out this section of the 3 reads template. Please pause this video and work on the lesson 2 level 3 problems in the workbook. Once you finish the lesson 2 level 3 problems in the workbook, you can stop this video and move on to the next video for lesson 3.